All right, it is the year of our Lord 2026, and it has been a while since I've done a assembly guide for the Synthwave kit. This is the Synthwave Pro specifically. There are very few differences, and most stuff is transferable. I'll try to cover any differences here to cover the whole thing and get you going. So here we have the chassis and our drive motors. These are brushless drive motors. Along with two of my drive motor mount plates. Those are aluminum, and our mounting hardware for both the plates to the chassis and for the motors to the plates. We'll go over that as we get everything out here. We've got our brushless motor made of the gearbox. These are Repeat Robotics motors. We do a lot of work with Repeat. They're fantastic. Again, these are our aluminum drive mount plates. Getting all M2 screws ready here. What we're going to do is we're actually going to line up. We did 4 holes here for whatever way you want to or need to mount your motor. We're going to get one screw in, line things up, and kind of keep it in place. I'm going to get a little bit of blue Loctite. We're going to be using a lot of blue Loctite during this build. One to hold, but not so bad that we have to use a bunch of heat to get it off, so we'll use blue. Put that in there. And we're going to go back and pull the other screw that we didn't Loctite. We just kind of put in there to hold it in place. And we'll go ahead and Loctite it. If we can get it out here, there we go. Go ahead and get it locked back down there. Just double check that both of them are tight. And that's one drive side down. Now we're going to repeat on the next side. Since we just saw this, I'm going to go ahead and fast forward a little bit here. You can see what's going on, but we know the steps. All right, now we're going to get into installation, which there are 2 ways to do it. You can do it the way I'm doing it here, where you just kind of slide everything in after installation, or you can start with the motor inside and then mount the plate from the outside, and that'll keep you from having to bend the wires back like that. They're strong enough that shouldn't be a problem as long as you're not crazy about smashing them there. But you line it up with the wires pointed diagonally towards the front and top of the case, and then you're going to start your screws in here into the 4 holes. Doesn't really matter which order, kind of do it opposite just to keep things lined up well, but it doesn't really matter. With these snugging down into the plastic, backing out usually isn't an issue. So we don't apply Loctite here. Then we're going to go ahead and repeat on the other side. And that brings us to the end of our drive motor installation. Everything's turning well. Now we're going to move on to our axle installation. We're using an M3 by 8 screws here, and our longer drive axles, I believe they're 22 millimeters. Longer Antweight Repeat Robotics drive axles. I'm going to poke the 3 millimeter screw through from the inside. Put some blue Loctite on the threads here. And then we're going to spin the axle on to the screw. Get it as snug as we can. We'll go ahead and repeat the process for the other side. Now we're going to start wiring up our speed controllers. Here we're going to start with the dual brushless speed controller for drive. So you can see you've got the two different signal connectors coming off there. You got the 3-wire and the 1. And then you've got your power in that red and black there. And the 6 contact pads for connecting brushless drive motors. We'll start by tinning the contact pads. Got my soldering iron here. Got the fattest blade tip I have on there. I recommend that for most of this because it transfers heat really well. You don't really need fine soldering for this. Just getting those tinned. Find it easiest to start with the one furthest away from my soldering iron hand and work towards my hand. That way I'm not having to cross over an already tinned pad and potentially remelt it or bridge the two. And we're going to choose a side. Generally, especially if you're concerned about space inside the robot, I would shorten these a little bit. You could probably do with about half their length as it is. I'm going to leave as much room for configuration as possible. You can really arrange the internals a number of different ways and they'll fit, but my preferred method would be having them shorter. Leaving these, as an example, I'm leaving these full length and they can be, that way this speed controller can be placed in a number of different places inside the chassis. Again, working from furthest away to closest, and I'm doing applying heat really more to the pad and then to the wire. If you can do it at an angle where your blade is touching both the pad and the wire, just long enough to get it reliquefied and then pulling off. You don't need to put a ton of heat into this. Now we're going to see what the easiest way to get this thing to lay how we want it to. You can do it on the robot, just prefer not to. Flat surface is easier. Again, starting furthest away from me. reflowing that solder, getting the lead stuck in there. You may have to swap these wires around if when you go to mix your radio, if there's a side that is backwards, you can change its polarity by changing any two wires on that side. But, you know, we got to choose a starting point. So we're going to choose this as a starting point. Go from there. Now we've got our XT30, our FingerTech switch, and our power distribution board here. We're going to go ahead and do our input, our incoming power wiring, and power distribution wiring now. Tinning the contacts on the switch. I like to do the ones on the bottom side. I like to tin the bottom side of each of the contacts on this switch. It lets me keep wiring lower in the chassis when the switch is installed. And when you pull everything out, everything tends to end up higher, so that checks out. These wires don't need to be quite as long as they were. We're going to trim them up a little bit, and then I'm going to split this one in half. It doesn't really matter whether you do the hot or the common side of your input across the switch. There's an argument to be made for either, but I just did the hot side here. Stripping these back as well. And then we're going to get them tinned and get them soldered in place. Now we're going to tin the power distribution board. And this is probably the hardest one to do because it's really just two giant pads, positive and negative, and the solder doesn't really love staying where you want it to be. So you're going to get flow through from front to back, and heat transfer from front to back to different contacts on either side when you're soldering. So take your time, double check all your connections multiple times when you're soldering to your power distribution boards, and let heat dissipate between soldering if you can, at least on the same side, to make sure that when you go to solder your second wire, your first doesn't come free. Anyway, so we're going to go ahead and get our XT30 incoming power connector positive wire soldered to the switch here. We're going to put on some heat shrink first. You can't put it on afterwards. Put it on first. And clean the iron tip a little bit, and then go in and wish I had another hand here. I have some helping hands, but I'm trying to show how to do this with as few tools as possible. So not everybody has a full set of tools like this, so there we go. Got that on there, give it a little tug, make sure it's solid. It felt like I could use a little more solder on there, so we're going to go back, add a little bit. Don't be worried if your connection comes loose while you're doing that. You can, so long as the solder's still flowing, you can go ahead and put it back in place. We'll do it as many times as we can to make sure you guys see it. Now, don't worry if it doesn't go right the first time. You can just reposition it. A little bit of heat. We're going to tin the top side of the other tab as well. And go ahead and solder the wire on there that we're going to take from the switch to the power distribution board. Yep. You know what, just to make sure this goes well, let's go ahead and slide down this heat shrink and shrink it. Now I'm going to use a hot air gun. This can be done with a hot air gun. This can be done with a lighter. This can be done with a soldering iron. If you want to use a little bit further down the iron and just run it across there till it shrinks up, just be careful. A number of ways to do this. Just get it hot. It'll shrink up. Now we know we're not going to get any bridges with our solder when we go to solder on the next wire here. I fumble with trying to get this to sit how I want it to. That's good enough. Nope, not good enough. Let's try again. Third time's the charm. It's like a USB port. Add a little bit of heat. Now this one you can put the heat shrink on afterwards because the other end is loose. And that was hot. So we can get it on there. There we go. There's focus. Get it on there. Go ahead and put the heat shrink on. And I think we'll go ahead and shrink that. When you're doing heat shrink, do go all the way around the sleeve as it reacts all the way around. Applying heat from one side won't force the whole reaction around the piece of heat shrink. You have to go all the way around it to get it to shrink up on all sides. All right, now we will go ahead and solder our incoming power to our power distribution board. Now, the way I like to solder these, I want a little bit more exposed wire on the end here, so I'm going to strip these back a little further. Again, this is more of a preference thing, not necessarily a good or bad amount of wire exposed, just this is my preference. Going to strip it back a little more. Tin these. I'm going to put these on the, I guess what is currently the topmost pads on the power distribution board. But I want them to kind of be linear. So I want the incoming power, the way the incoming power is lined up is coming from that top side. And these pads are off to the side, kind of like a T. But that shape is hard to heat shrink. So I'm going to reorient the way the wires are coming away from the board so that it maintains that linear flow of wire to make this easier to heat shrink. If that makes any sense. It'll be easier to see once we get to it, but we're going to go the top with these ones. And thank God we didn't loosen any other connections while we were soldering those in. Now we're going to jump on to the weapon support assembly. We have bearing here and our bearing retention plate along with the right weapon support. So we're going to pop that in here. We've got 4 M3 by 8 screws. With a number 2 hex drive. We'll put some Loctite on there, some blue Loctite, and get that threaded in here on camera. There we go. Somewhat on camera. Bear with me here. All right, and the retention plate is threaded, so we're just screwing into that through the plastic into the retention plate. This one, I do kind of feel like it's important to go opposites like you would a wheel. And to be careful how much you snug it down. The plate's not going to sit flush against the weapon support, it will sit flush against the bearing. The bearing will sit flush with its flange against the weapon support. So when you do your first screw, tighten it till it's about flat so you can hold the weapon support and the retention plate flat against the bearing on either side of the flange. And then from there, you can kind of see how tight it needs to go. You're going to do it in alternating sides so it stays flat. And there we go. That is the right weapon support. I've got the left and the stator for the weapon motor. So the spacing for the motor mount holes is asymmetrical. Two are closer than the other two. You're going to line those up so that the wires come backward. There's a little slot, like a little channel, that the wires are going to fold into. See that as you go. We'll go ahead and grab some Loctite. Again, blue Loctite's our best friend. This one's old, so it doesn't like to squeeze out, but we'll get it out. First one, it's easiest to just start it through and then line up the hole. There you go. Once you get that one in there, you can kind of look from the back and line up the holes from there. I'll try to show you what I'm talking about now. So I made a little adjustment there. You can see the bearing on the back of the stator through the hole on the weapon support there. It's that shiny bit in the middle. If it were not lined up, you would just see black there. We're going to go alternating pattern here, just like we would on a car wheel. Try to keep things flat. This is the super fun part where you get to watch me turn a Allen wrench for 10 minutes, but you'll get the idea. All right, our last bolt. As you can see, those wires are going backwards. We'll just come back in and clean off the excess Loctite here. It's on the back side there. It's not doing any good, so got that cleaned up. And there's the rest of the weapon assembly here we can pop on. Yeah, I just want to show you how these wires tuck into this channel. This is crucial for assembly. Make sure you don't cut a weapon wire or pinch a weapon wire. There's a channel right in there that they tuck into, and that matches up with the channel on the chassis when you put the weapon supports on the chassis. It also keeps the nuts holding the blade on from interfering at all with the wires. So it spins freely like this. And then that bearing goes onto the shaft on the other side, and the weapon is fully supported. So here we're going to get the M3x30 chassis bolts and nuts, the nylon lock nuts, to hold the weapon assembly in place in the chassis. Can get things lined up here with that wire, following the wire channel in the chassis that we talked about earlier. Can take a little bit of doing, but this is pretty vital to make sure that they are in the channel you'll see in the chassis that lines up with the channel in the weapon support. Try to get everything seated where that's in place, and then all of the weapon supports are touching all the way across on the chassis. We're going to take the bolts, take the first one, start it in from the bottom, and this is going to take a minute and be pretty grueling on your wrist, but it's necessary. Make sure you're holding the weapon support down against the chassis while you're doing this, as we're going to be cutting threads as we go, and so we need to make sure it doesn't push it up at all. I'm going to go ahead and speed this up for your sake. Unfortunately, you will have to suffer through this when you do it, but it's pretty much a one-time thing. You can run all these through, again, making sure to line them up properly and keep force down while you're doing it on the weapon support. Keep it snug against the chassis. And there we go. All those posts are in. Now we're going to look at the weapon speed controller. Got some heat shrink to cover it up once we're done with making sure that everything is wired correctly. And then we have some barrel connectors. We're going to use those. I'll match up with the barrel connectors on the ends of the weapon motor wires. So we're going to get 3 lengths of wire here. They don't need to be super long, just long enough to give you a little bit of freedom from the ESC in case you need to route them. You kind of want to route them back over itself. You'll see that when we get to putting the weapon speed controller in the chassis. But I don't know, maybe 1.5 inches, 2 inches. I'm gonna strip these back. We're gonna tin all of these ends that we just exposed here. Now we're going to prepare these barrel connectors for the wires and get them soldered in there. There's a little hole on the side as well as the top, and we're going to utilize that. So I'm going to get the connector with the cup facing up. Then I'm going to put the solder through the hole on the side, which goes into that little cup there, and then we're going to apply heat from the top of the cup. It'll take a minute, but it will start melting, and just keep feeding the solder in from the side until it fills up the cup enough for you to get the wire kind of submerged into solder when you go to solder it. I like to go over halfway full. 3/4 feels like a good amount. That way when you add the wire in, it doesn't displace so much solder it's spilling over the sides. Keep the cup heated, put the wire in there, and you're going to watch the solder in the cup until it changes sheen. It'll go from being super shiny to a little bit more matte. You'll come to recognize that as solder being solid again. And once it does that, you can pull it out. There we go. A little bit of spill on the side from trying to feed that solder in through the side of the hole, but it'll do. Now we're going to speed through these as well. Again, same steps. You can go in from the top and from the side. Doesn't really matter, whichever one you're more comfortable doing. Both of them work. I use both methods here. I use both methods pretty regularly. It just depends on which one seems to be working better for me at the time. Now we're going to heat shrink these barrel connectors. And so for this, what you're going to do is slide it over there, slide the included heat shrink over the end, and I want to put the end of the barrel on the table so the heat shrink sits flush with the end of the barrel, just like this. Right? That way when you heat shrink it, you're not going to have a bunch of exposed barrel down at the end that can touch with other ones. It's also not going to shrink over the end of the hole and make it difficult to remove or insert the mating connector there. So we're going to shrink this up, rotating as we go. I kind of want to show you what it looks like here when it's done. See, it's pretty flush, as flush as we can get it with the end. If it's not perfect, that's okay, but you don't want a bunch of exposed copper, and you don't want a bunch of overhang either. So we'll do the same thing with these two. Then we're going to tin the speed controller contacts here, the pads like we've been doing on the other speed controller. Or ESC. If you're unfamiliar, I think I've used the term ESC here. It's just electronic speed controller. That's what these are. So we're going to tin these and go ahead and solder our leads on here. I'll speed through these. And then we have our heat shrink. We're going to fit this on here, but not shrink it yet. We want to make sure our polarity is right. And you know what? This is a step that is probably best practice. Probably best practice to wait, though, with the bullet connectors. It's actually not necessary to wait. We could go ahead and shrink this down, but when you're putting together fighting robots, a lot of times you don't have bullet connectors on there. If you want the extra security of solder, you can do that. If you don't have bullet connectors on your motor, So for this specific instance, we could go ahead and shrink down that heat shrink, but we're not going to yet. You want to feed these wires through the heat shrink on the power side, on the outgoing power side of your power distribution board, just like I've done here. That way you can shrink it all up together when we're done soldering on these power wires to our PD board. We're going to go ahead and add a little bit more solder back to these pads we're going to use. Again, use your best judgment. You want enough that you can kind of remelt the solder a little bit and get the wire in there quickly, which is easier with more and fresh solder. Just don't overdo it. Don't bridge anything. We added some back here. Now we're going to line these up and get them tacked down. And I'm going to use tweezers to keep this in place. You could use some needle nose if you have those instead, but you don't need a lot of pressure here. Just trying to keep it where I want it to be while it's drying or cooling off. Let me know, do you think solder dries or cools off? How would you phrase it? I've kind of used both interchangeably here, but it's kind of doing both. Anyway, we're going to see how we have all of these coming out the bottom where the opposite end of the incoming power is. We're going to double check all of our connections. Like I mentioned before, we do that so that we can slide this heat shrink back up and over. It's a little snug. It wouldn't be the worst idea to stick this heat shrink over the end of a needle nose before you put it on there, and you can open them up like that and stretch it out a little bit, but we'll get it on there, get it shrunk back down. With this thicker shrink, it takes a minute to shrink back down, but we also have the adhesive on there to make sure nothing's moving around. I do recommend the adhesive lined heat shrink for robots because it kind of adds another layer of security, keeping things in place. I've got our receiver here, our battery. Do some checks on our wiring. So here is how you're going to want to hook up your drive motors. You've got the bottom two are going to be your drive. Channels 1 and 2 are going to be your drive. We're going to hook up our battery here, just so everything's still open. We're not hooking up the weapon. We don't do that outside of a test box, or another safe test setup would perhaps be setting it up in a garage with a phone where you can watch from the other room, but not not doing it anywhere where the robot is in a room with the person. So here's how you're going to want to set up the mix for drive. This is on FSi6. This is what comes with the kit if you get it pre-assembled, or if you get it with the radio. And those mix settings are pretty easy to find elsewhere, but I thought I'd go ahead and show them here as well. And that'll give you forward rotation when you push forward on the stick for both. Rear rotation, we push backward on the stick for both. Left will have the left side turning backward, the right side turning forward, and then vice versa for right. That's how you want it mixed for single stick tank steering, which is the standard in combat robotics. If you want to do something else, get after it. All right, so this is how you'd hook up for weapons testing. So you've got it turned off here. So we're going to hook up the weapon assembly. Not power it up yet, but we're going to get it hooked up so that we can do the testing. And we'll get everything in here. There's 100 different ways to do this. Everything fits at least 3 or 4 different ways that I have personally tested. But that's kind of also optional how you want to do that. We do have to go ahead and hold that switch down. We're going to put the switch retention screw in through the side from the outside into the hole in the switch which is nearest the wires. We do that so it lines up with the power switch hole on the shell, on the lid. You want that guy pretty tight because you want to be able to put your Allen key in there and have the switch not rotate around that screw. Everything in, shell on. You can see it lines up there with that hole. We're going to put the nuts on, these nylock nuts. Tighten those down. I'm going to put some more of these number 4 screws in here. In the corners, just kind of keep the lid from flapping around too much. Anything from spilling out. And then put on the wheels here. Pretty easy on the rear wheels here. You're just going to take off the face of the repeat hub. Then it all comes apart pretty easy for getting in place. Take those 2 countersunk screws out. Plate's going to come out, and then the wheel assembly kind of comes apart pretty easy like that. You're going to look for the grub screw on the hub, and you're going to put that in line with the flat on the D shaft of the drive motors. So you've got it in line there. And I'm going to put the pulley back on here for spacing reasons. You'll see why in a second. I'm going to slide it back over. There we go. Just carefully push it down till the base of the pulley is just barely touching those screws that mount the drive motor in. make sure we have plenty of clearance. And now I'm going to tighten down that repeat hub grub screw. That's going to set our spacing away from the body. See, still turns freely. Whoop. Make sure it's really good and locked down there. And we put the pulley back on. It's keyed, so it stays on there and doesn't spin in place. The wheel is also keyed. And now we're going to just reverse the process of disassembly we just did. Popping this guy back on there. Putting these countersunk M3 screws back in to hold the plate to the rest of the hub, and makes a sandwich with the wheel and the pulley. I love these repeat Echo hubs. Snug this back down. Probably hold that, tighten it the rest of the way. All right, still spins freely. Let's do both front and back on this side. So this has a bearing, a flange bearing pressed into the printed hub with the pulley. That is also like the repeat hub. This is flanged, or it's keyed with the wheel, and it is holding the wheel in compression as well between the two so that it's not going anywhere. Then we're going to take a M3 by 8 screw, put it in the outside of the axle here. And that's going to retain the bearing on the shaft and won't let it come off. Whoop, get it down nice and tight. All right, now I'll do the other side. Fast forward here, same thing, other side. Get the rear wheel on. The front wheel on. And then we'll put the belts on. These are our drive belts. They transfer power from the rear direct drive wheels to the front ones. And do this in this order. It makes it way easier. Go over the front wheel, all the way down to the shaft, then over the rear wheel, and then put it on the pulley, and then slide your finger along the path of the pulley on the front, and the belt will follow, and there. Super simple. And same process over the front, go all the way down to the shaft, past the pulley. Now get the rear one on, put it on the pulley, follow it along the path to the front pulley, and there it's on, and it's snug enough that turning either wheel turns both wheels. And there it is. Now you're going to go to your nearest test box and get the weapon tested. Any reversing that needs done with the weapon there, just pop the cover back off, swap two of the bullet connectors around, any two, and it'll swap its orientation. You guys are good to go.